Good days, ladies and gentlemen. We are Group 4 and our project is about building a smart healthcare monitoring system with AWS cloud services. So first of all, let's have a rough idea of what is the healthcare. Healthcare is the process of maintenance or improvement of an individual health via prevention, diagnosis, amelioration, or healing from any illness, disease, or physical and mental injuries. So there are three levels of healthcare services, which are the primary, secondary, and also tertiary level, and our system provides only the primary care level services, which is the services that can be obtained from almost all the clinic that take care for most of the medical concerns and symptoms like fever, food poisoning, and etc. So for the history of healthcare monitoring system, in the older time, the only device that used to monitor the user vital sign is the cardio stethoscope, which display the vital signs in a single waveform and red number on screen. Then Philips improved the design to make it lighter and also easier to carry, which called the Philips IntelliView family of patient monitoring system in the early 2000s. After that, with the advancement of the Wi-Fi technology and Internet of Things, the use of wearable sensor to collect the vital sign data from the users with the 3G network to transmit the data has been introduced. Several years later, the use of Raspberry Pi, which used as a microcontroller with the Internet of Things sensors, has been proposed as well. Then eventually, with the rapid development of the cloud computing, a new model which still using the Internet of Things but with the combination of cloud services is introduced, which then become a guideline for us to develop the proposed system.
Good afternoon, sir. My name is Jia Cheng Hang, and I'm going to present about future trend and also problem statement. So, in future trend, in the past, people are unable to check their health data such like stress level, blood oxygen level anytime without using professional tools. Smart healthcare monitoring system is start to evolve and improve that it can even be operated by linking with smart sensors such as heart rate monitoring and oximeter sensor in a smartwatch to collect and store the user health data. Besides that, it is time-consuming and costly for users to constantly depend on doctor or healthcare professional to monitor their health. Thus, new technology has been introduced to be accessible to users to automatically monitor their health. Smart healthcare monitoring system is an efficient alternative as it eliminates the dependence of doctor and medical personnel. Furthermore, AI health condition prediction may be implemented in the future into the system to provide users with a better preparation. This prediction algorithm may learn from the accumulated health data stored and predict any future health condition that may occur. Next, let's move into the problem statement. Nowadays, people are lacking of the awareness on living a healthy lifestyle due to busy and stressful lifestyle. They often neglect about their health condition in their daily life as large amount of time are occupied by work or studies. Accumulation of the health problem for long term will cause serious illness or effect on their body. People nowadays are so busy until they are lacking the time to perform regular health checking at clinic or hospital. It's because the medical checkup process may often take between 2 to 4 hours depending on the package selected. The third one is that the market does provide the user with different equipment to perform simple health tests at home. However, users will get annoyed when they need to perform health tests and interpret the result themselves. They often like to achieve the goal with minimal steps.
We will now proceed with the objectives and proposed solution. The first objective of this project is to develop a cloud solution for the user to monitor their health condition in real time at anywhere and anytime, and to obtain accurate health report over a period. The other objective of the project is to develop a cloud solution that will analyze user food calories. In this project, AWS will be the platform for us to provide the solution for the users. This solution works by first collecting the smartwatch sensor data such as stress level, blood oxygen saturation, heart rate, and the weight and height data. The health data will then be sent to corresponding cloud services and used to perform health analysis automatically to notify users about their health condition in real time. Besides that, the health data will also be kept inside the cloud storage for visualization purposes to be inserted in the health report. The health report will be sent to the user's email periodically to help user familiarize with their health condition in long terms. Besides that, user can also snap and upload the food image they eat and the cloud solution will analyze whether the food is suitable and healthy to eat. The cloud solution will recognize the food and the corresponding calories. The food calories result will be sent to the user via email to help them to plan a better diet in the future. Next is the architecture diagram of the proposed solution. Amazon Web Services are used to develop the smart healthcare monitoring system. As shown in the architecture diagram above, we can observe that there is a total of 8 services that we are introduced and linked together to build this project. The AWS services utilized include AWS IoT Core, Amazon API Gateway, Amazon S3, Amazon Recognition, AWS Lambda, Amazon SNS, Amazon QuickSight, and Amazon RDS. Nevertheless, all the services will operate and interact with each other to accomplish the proposed solution. That is all for the architecture diagram. We will now proceed with the study of different cloud platforms. Firstly, AWS is a cloud platform that offers a wide range of infrastructure as a service (IaaS) and platform as a service (PaaS) and allows users to build business solutions using the integrated web services. Besides that, AWS allows customization of infrastructure requirements, which would have cost more if done on on-premises. On the other hand, Google Cloud Platform GCP is a part of the Google Cloud and is a public cloud vendor that allows users to access Google's computer resources for free or on pay-per-user basis. Next, Azure is a Microsoft public cloud platform, and like AWS, it offers a broad collection of services such as PaaS, IaaS, and database services. Besides that, Azure allows users to access and manage cloud services provided by Microsoft and provides an extensive array of solutions for a multitude of industries. The table below shows the comparison between the relevant services provided by AWS, Azure, and Google Cloud.
I will be present the part 1, Health Sensor Data Analyzer. Firstly, we subscribe to a topic that named IoT Health Data. So after subscribe it, we are published to a topic that the name is same as the previous topic, IoT Health Data, and we will be publish the sensor data from the smartwatch. So after I publish it, the data will be triggered the AWS IoT rules, which will be execute the rules query statement, which is will select the sensor data and from the IoT Health Data topic, and then it will send this data into the Lambda function, which is Health Data Analyzer. So let's go to the Health Data Analyzer function. In this Lambda function, we will be creating a SNS client and also a Lambda client. We get the value that passed from the AWS IoT and we store it in a variable. After that, we will be create a message test. We will be attach the message after checking the abnormality. So we put this sensor data into the input parameter of a JSON format, and we will involve another function which called RDS user health data lambda function. So let's go to the RDS user health data lambda function. This function is used to store the sensor data into the database. So we will be configure the database connection by adding the endpoint username, password, and also the database name, which is user health. The endpoint we will be getting from a Amazon RDS, which is an instance to host the MySQL database. And the endpoint is getting from here, and we attach it into the Lambda function, and we will be establish the connection. After that, we get the value that passed from the caller from the Health Data Analyzer, get the data and store inside a variable. After that, we will using this variable to create a query, which is will insert into the health table, and then we will be execute the query. So after execute it, we can see that in the previous table it only consists of 1001 UID record. So let's refresh the table. This table is a table named health under a user health database. So after we refresh it, we can see that 1002 record has been added into the table. Okay, let's go back to the Health Data Analyzer. So after adding the data, we will be sending the email about the user report through SNS AWS. So we will be sending this email according to the topic ARN, which will be attaching with the UID of the user. So let's go to the SNS Amazon. We can see that in the UID of 10002 is under a subscription of an email named oskarjia2@gmail.com. So in this email, you will be receiving an AWS notification stated that the stress level is abnormal. This is a AWS quick site. So we get the data from the database named user help. This user help database is from the database that we previously stored the user help sensor data. So we are also able to view the graph of the data. As for this graph, we are using the heart rate as a y-axis and the date uploaded as an x-axis, and it belongs to a UID of 1001.
So now I'm going to explain the second functions in our proposed solutions, which is a food calorie analyzer. So first of all, we have created an API to upload the food image to the S3 bucket. So now I'm going to copy the API URL and paste it inside the Postman to execute the request. Next, I'm going to put the bucket name and also the file name. The file name is divided into two parts. The first part is user ID to indicate which user uploaded the food image, and then the second part is the food name. Next, I'm going to select the Apple image from my local device, and then I hit the send button. The status code 200 means that the API request has been sent successfully. After that, the help user food bucket will shows the food image uploaded just now. And then the food calories analyzer will be triggered by the object created by food events inside the help user food bucket. Besides, I also add the destinations inside these Lambda functions so that I can invoke other Lambda functions known as food calories delivery functions, which I will explain later. Now, we're going to focus into the code of food calories analyzer functions. First of all, I have created a client for recognitions, Lambda, and SNS service. Next, I retrieve the file name from S3 object creation events. In this case, it's 1001 apple.jpg. Next, I split the file names to get the UID for the usage of Amazon SNS meter. Next, I invoke the detect labels method of Amazon recognitions to detect the label of image by passing the bucket name and also the file name. Next, I put the return label into the input parameters to be passed to the food calorie query functions. And then the next ones, I will invoke the food calories query functions to get the food calories informations by passing the function name, the invocation type, and then the payload. Next, I'm going to explain the food calories query functions. Before that, I have my SQL workbench connecting with the RDS database instance. And inside my SQL workbench, I have a food database, and inside I have inserted a calories table. So in Lambda functions, I configure the database connections by copy and paste the endpoint to the endpoint variable, the username, password, and also the database name. The database name can be found here. Next, I establish a connections by invoking the connect methods and passing the parameters such as endpoint, username, password, and database name. Next, I read the query passed by the caller. In this case, it's Apple, and then I write and execute the queries to get the calories informations in the calories table. If the query result is not empty, the message will be compiled, and it will consist of the food name, the calories, and then the serving size. Else the message will be compiled like this. After that, the message will be returned to the caller. So we back to the first Lambda functions. So the response from the second Lambda functions will be assigned to the message variable. And then the food carries informations will be passed to the user, passed to the particular user using the UID by evoking the publish method from the Amazon SNS. The parameters requires topic ARN, message, and also the subject. Before that, I have created the two topics inside the Amazon SNS. This topic's names is assigned with the user ID, and each topics have a subscriber email. Then the food carries information can be sent to the particular user by changing the topic ARNs dynamically. So I have altered the topic ARN by replacing the last part of the topic ARN with user ID so that it can be run dynamically. After that, I'm going to show the result sent to the subscriber in the Gmail. So this is the message that will be received by a subscriber after they upload the food images. So that's all for group presentations. Thank you.